Hello, Algebra 1 students. For Fry, Mr. Leininger, whoever the sub is at the time, you are looking at this worksheet. It really doesn't have a name, but the function rule. So you're writing a function rule that represents each sentence. And so I went ahead and I did number 8. You're pretty much just translating these into equations. Basically, that's what they mean by, writing a function rule. So y is 5 less than the product of 4 and x. So I have y equals 4x minus 5. Just translate it from, a phrase into an algebraic expression. So actually, equation, because it says is means equals. Whenever you see is, that means equals. So C is 8 more than half of n. So C is 8 more than half of n. And, half of n would be n divided by 2. If you want to, you could write it like this. C is, and you could have the 8 first too. I just wrote that as an example. It doesn't matter because addition is commutative. Half of n, so half times n, or n divided by 2 will give you the same answer if you were to put any values in there. 2.5 more than the quotient of h and 3 is w. So I have the quotient of h and 3 and 2.5 more than that, and that is w, it equals w. Then we have some more situations here. So number 13, the price P of a pizza is $6.95 plus 95 cents for each topping T on the pizza. The way you're going to do that is P is going to equal that $6.95 standard cost no matter what, plus 95 cents per topping. So you could, plug in for toppings. I want 2 toppings, and you can figure out your price of your pizza. $6.95 times 0.95 or plus 0.95 times 2 if you had 2 toppings. I would prefer mushrooms and olives. So there's my 2. 15. We have 15. The almond extract A remaining in an 8-ounce bottle decreases by 1/6 ounce for each batch B of waffle cookies made. So I start off with 8 ounces, and I'm subtracting 1/6 for every batch, and that's going to be what's left in that almond extract. 17, a team of divers assembles at an elevation of 10 feet below relative to the surface of the water, and then the team dives at a rate of 50 feet per minute. Write a rule representing the team's depth in the function of time, and then figure out what the depth after 3 minutes would be. So here is the equation. The depth is going to equal, so they start at negative 10, and then they go a negative 50 more per minute. So 3 minutes, I plug that in for T to figure out the second half of the problem, and these divers would be at negative 160 feet. 19, write a function rule for the area of a triangle with a base 3 centimeters greater than 5 times its height. What is the area of a triangle when the height is at 6 centimeters? So here you got to remember the formula for a triangle area. Area equals half base times height. So I have half this and half that. So half this, half that. And then I got to put a 6 in the height in with both of these when I'm figuring out the answer for the question, and it would come up to be 99 centimeters squared. Hopefully you're slowing this down, stopping it, taking a look at these problems, writing this out, because I know I am going rather quickly. It's just easier to download when it's a quicker video, because I have others that I have to put up for other classes. So hopefully that that explains it more thoroughly. This would be your equation, and then this is answering the question for a height of 6. And the reason why we divided by 2, because the formula is half base times height. So we took half of 3 and half of the 5, half of both of those. But we have to factor in the 6 because they ask us, what about when the height is 6? 21, write a function rule for the area of a rectangle with a length 2 feet less than 3 times its width. And what is the area of a rectangle when its width is 2 feet? So you got to remember, it's the area is length times width. And we are going to, and that's going to be squared. So we have A equals area is going to equal 3W squared, and we're going to subtract that 2W. It's 2 feet less than 3 times its width, so 2 feet less than 3 times the width. So when the width is 2, we just plug in 2 for our W's, and then we figure out that it would be 8 feet. Okay, going on to the back of this other side. What advantage can you see of having a rule instead of a table of values to represent a function? Now, you can write whatever you want here, but the basic idea is this, that it's easier to plug any value into the problem and solve. You know the function rule. So coming up with a function rule, you don't know if the function rule, you have to figure out the function rule when you are looking at just a table of values. But here, I know what the, if I know the function rule, if I know a problem, if I could just plug in any value and figure out my answer. For 25, looking at the whales, from an elevation of 3.5 meters below the surface of the water, a northern bottlenose whale dives at a rate of 1.8 meters per second. Write a rule that gives the whale's depth as d as a function of time in minutes. What is the whale's depth after 4 minutes? So basically, starting at 3.1 and then going down 1.8 per meter or per minute. Right here, this means minute. This means meter down here. So in my equation, this is minute, but in my answer, I was figuring out for minutes. So MIN, I should kind of squeeze it in there. So I substitute 4 in for minutes, and then I could figure out that whale is going to be at negative 435.5 meters. That is meters. Sorry about that. This is, after 4 minutes, this is my minutes, this is my meters. That's how I should be wording this. Okay, number 27, working on tips. I have, you go to dinner and decide to leave a 15% tip. Sorry, I was just taking a drink and it went down the wrong way. You had $55 when you entered the restaurant. Make a table showing how much money you would have left after buying a meal that cost 15, 21, 24, or 30. So this is the formula for that. That's the function rule. Okay, so this would be your cost, and it's subtracting 15%. So I'm going to take that 55 and it's 1.15 because, I made the mistake of just having it 0.15 because that's 15%, but it's the cost of the meal and the 15%. So that's why it's 115%. So 100% of the meal and 0.15 or 15% of that meal. So that's why this works a lot better. When you figure it out and you make this graph, or not graph, but this table, sorry, you plug in 15, you end up getting 37.75. That 55 minus 1.115 times 15. When you put in for C 21, you end up getting $30.85 left. When you put in 24, you end up getting $27.40 left. And when you plug in 30 for the cost, the meal cost, you get what's left, is $20.50. When you graph that, so here's A, here's B, here's C, and you could be writing this on your own paper because I wanted to show you both, but it will look a lot neater. I just did a little by tens chart here, where I have the meal cost or the meal, or how much money. I'm sorry, I have how much money is over here, and then this is going to be along with the cost. And so you could see I just took these values, the cost, and how much money is left. This is the money that's left over here, and I just plotted those points, and you could see that it is a linear equation going down with a negative slope. 29. You consult your new projector's instruction manual before mounting it on the wall. The manual says to multiply the desired image width by 1.8 to find the correct distance of the projector lens from the wall. So write a rule to describe the distance of the lens from the wall as a function of desired image width. So it's just going to be, the width times 1.8 will give you the distance from the wall. So you have D equals W times 1.8. That is a 1.8 there. And then B, the diagram shows the room in which the projector will be installed. Will you be able to project an image 7 feet wide? Well, 7 times 1.8 equals 12.6. And this room is only 12 feet. So I can't go 12.6 here. So no, I won't be able to do it. Will you be able to? So no, because the room isn't big enough, however you want to put that for B. No, because the room isn't big enough, I guess would be the way you'd want to word that. C, what is the maximum image width that you can project in the room? Well, the maximum, I just took that 12. 12 is as far back as I can go, it says. So, and I'm still using that formula W 1.8. So I divide both sides by 1.8, and I get 6 2/3. 6 2/3 of a foot wide is how big I could get it in that room that's right there. Okay, hopefully this helps.